right, I need you to go to the second to the last page where it says pre-calc exponential growth and decay application. All right, so today is about the application. So there's going to be a situation, there are numbers, you have to figure out what that means and then find out what the question's asking me to find, okay? All right, exponential growth or decay, a quantity increased by a fixed percentage at regular interval. It'll be exponential growth. The key word here is increase on a fixed percentage at regular interval. So let's look at the example. Cases increase by 15% in a every day, same interval. Saving account balance with 5% interest compounded quarterly. So it increases quarterly, same fixed interval. Home value appreciate means it goes up, it gets bigger, 2% each year. So do you see all three things have in common? The same amount, same rate, not some amount, excuse me, same rate on a fixed amount. All right, then what is exponential decay? Quantity that decreased by a fixed percentage at regular intervals. So growth is getting bigger, decay is getting smaller on a fixed rate. Okay, city population decreased by 2% each year. Car value depreciate 10% each year. Stock loses 10% each week. All right. Good news, I guess. We did this last year in Algebra 2. And if you remember one thing, you cannot use that percentage when you plug it into the formula, which we're going to talk about in a second. Do you all remember that instead of using the percentage, we're supposed to use the decimal? That's right. So you move decimal 2 to the left from the percentage to get to it. So for the 15%, your R is going to be 0.15. So move your decimal 2 to the left. R will be 0.05. R will be 0.02. So always be careful with that. Same thing over here. Okay? All right, so what is a formula or equation we use for the exponential growth and exponential decay? Exponential growth is y is equal to a times 1 plus r to the t power. Decay, y is equal to a times 1 minus r to the t exponent. So only difference between growth and decay is the plus and minus. Okay? Where a represents the initial value. So how many people do you have at the beginning? How much money did you put it at the beginning? Or what's the, yeah, all of that is the A, initial value. R is the rate, R over here in decimal. So remember we did that practice quickly here. Do not use 2 for that. Your R is going to be 0.02. Move it to the decimal, to the left. And T is going to be time. Okay, all right, so let's look at this right here and then identify each one. I'm going to do the right side first. All right, is this growth or decay? Just by looking at it. Well, your base is 1.12. So is it getting bigger or smaller? As x gets bigger, it's going to get bigger. So it's going to be exponential growth. So the base is greater than 1. Aha, that's actually last week's lesson, isn't it? Okay, all right, since it's a growing, you're going to find the growth factor. How do you find the growth factor? Growth factor is going to be your base of that exponent, which is 1.12. Okay, then what is growth rate? All right, and do you guys know that 1.12 is 1 plus 0.12? Remember, according to the formula, it is 1 plus r. 1 plus r. Right, so r is 0.12. However, for the growth rate, you need to give me answer in the percentage. So going from percentage to the rate, we move decimal 2 to the left. Now we go backward, 2 to the right. So it'll be 12%. Okay? All right. Let's do one more over here. Your base is 0.8. So as x gets bigger, it's going to get smaller, smaller. So it's actually decay. What is the decay factor? The base, 0.8. What is the decay rate? Well, where did I get that 0.8 from? It is over here. 1 minus what? 0.2, isn't it? 0.2? So your R is 0.2. In decimal, I want it in percentage, so you move decimal 2 to the right, 20%. That's how much it decreased each time, 20%. Okay? Next page. All right. A job has starting salary of $40,000 each year. You earn 2% wage. What is the initial value? You start with the 40,000. What is the rate of increase? You increase 2%, which is 0.02 decimal. What's the growth factor? So y is equal to a times 1 plus r to the t power 40,000, 1 plus 0.02 to the, sorry, you couldn't even see, t power 40,000, 1.02 to the t power. Your growth factor is the base, 1.02. How much will you make in 10 years? So I'm gonna plug 10 into the time, where the t is like that, and then plug it in my calculator. All right, this looks easy, but I actually encourage you to get your calculator out and then plug it in, because you might make a silly mistake here and there. So actually try it, okay? So 40,000 times parentheses 1.02. Where's the exponent again? The caret. Caret. 10th power. I make about $48,759.78. Oh my word. Like that. Does it make sense? Another thing, folks, is that how the rate is increasing every year, every month, every day has to match with what you plug in for the t. What do I mean by that? So over here it's each year. So for t I put 10 years. If this was after 6 months, what are we going to put for t here? 6? You have to convert that month into the year, so it has to match. How many years is 6 months? Half. So you'll put half for t. Does that make sense? Hopefully. Okay. All right. A city of 500,000 loses 1%. What's the initial value? 500,000. Rate of decrease, 1%, which is going to be 0.01. Decay factor is 1 minus 0.01, which is going to be 0.99. Population after 10 years, 500,000. 0.99 raised to the 10th power. You're going to plug that in your calculator. 452,191 people. Okay. Pause it for a second, because in the class I did some whiteboard practice, which you don't have whiteboard. So just get your notes. I think there's a blank side after your bell work, right? Okay, let's write it down. Ready? I'm making the problem up. Indiana has 20 bears. The population increases 10% every 6 years. Ooh. Got it? All right, I need to set up the equation that describes this. In fact, pause it and try to write it down. Be careful, every 6 years. Okay, so I hope you actually did it. Let's talk about it. So usually other problem we've been doing have been always said every year, right? Every month, every day, but this is every 6 years. So how I'm going to write it? Let me just quickly describe what is happening. So you start with the 20 bears, year 0. On year 6, there's going to be 10% increase of it, which is 2 more bears. So there's going to be 22 bears. So it's not happening every year, it's every 6 years. So your equation, y is equal to 20 initial value times 1 plus the rate. 10% is 0.1. I hope you all got to at least that point. How am I going to put every 6 year into the equation? It's going to be t over 6, like that. Right? So when t is 6, 6 over 6 is just a 1, so you're just doing the 10% of 20 increase, which is 22. Okay, so if it says every certain year, every certain month, every certain something, you're just going to divide your time by that. Does it make sense? Okay. Back to your notes. Let's finish it up. initial value. Sally's training for 5K. She started on day 1 by running 0.25 mile without stopping. Her goal is to increase without stopping by 10% each day. Initial value is, she start with the 0.25 mile. She wants to increase 10% each day, which is 0.1 in decimal. Growth factor is 1.1 because 1 plus 0.1 is 1.1. Now, let's find out initial value 1.1 raised to the t. So she wants to increase 10% each day. Day matches it, so I don't divide anything like that. And how many days are we looking at? 30 days. So I'm going to put 30 as a t. Plug it in my calculator. I got 4.36 miles. So, will she reach her goal of 3.1 mile 5K if she keeps doing it? Yes, yes, yes. Okay. All right, Dejan takes 20 milligrams of the drug to help with the symptom. Due to absorption in the body, drug loses 25% of its strength every hour. So growth or decay? Decay. All right, so start with the 20 milligrams. Rate of decrease is 25%, which is 0.25. Decay factor, 1 minus 0.25 is 0.75. 20 times 0.75 raised to the t power. It's every hour. I'm looking at 8 hours, so 8 is going to go in the t. So plug it in my calculator. I got 2.002. He needs at least 2 milligrams left in the body. So after 8 hours, will he need another dosage? I will say yes, he does. That doesn't go below 2. All right, good job with the notes.